Hey everyone. Today's launch is optional. This is a launch for you to do if you feel like you need practice differentiating between P naught and P hat. This is done as a request from some students because they're still a little bit confused on how to tell the difference between the two. If you feel like you've already mastered this, you can go ahead and just get started with our Edpuzzle video notes for today. You don't have to continue watching this. Today's launch is to go over how to differentiate between P naught and P hat. If you would like to watch a video while you complete the launch, click here. So there's going to be a link on this document for you. Any boxes in green means that you should type in or show work. If you feel like you mastered the skill, you may move on to the Edpuzzle video and notes. So let's start with number 1. Jason reads a report that says 80% of high school students have a computer. 80% of U.S. high school students have a computer at home. He believes that the proportion is smaller at 0.60 at his large rural high school. Jason chooses an SRS of 60 students and finds that 41 have computers at home. What is P naught and P hat in this situation? So this should actually say 0.8, and it should say 0.8 in your document. So the 0.8 here talks about the United States, right? And because we're talking about the United States, this is a huge population. This is a population that we're talking about. And P naught always represents the proportion for a population. Okay. So because the U.S. high school students is our population, P naught is going to be 80%. Now, P hat always comes from our sample. Think of P hat and X bar are the same thing, except one talks about proportion and one is average. And both of those are used to describe a sample. So in this case, P hat is 41 over 60, which is 0.683. So our P hat is 0.683. We want to write a hypothesis for this situation. Well, our null hypothesis is always what is stated. It's what's claimed. So that's P equals 0.8. Jason believes that the proportion is smaller than 0.8. So he's saying that his alternative hypothesis is P is less than 0.8. And that's how you would differentiate between P hat and P naught. Next. SF Chronicles reported that 13% of students typically walk to school. Enrica thinks that the proportion is higher than 0.13 at LPS. She sends out a survey to the entire senior class of 150 students. 17 of the 100 students that replied said they walked to school. What is P naught and P hat in this situation? What is the appropriate hypothesis? Well, SF Chronicles reports 13% of students, right? And because this is a reported number, this is going to be our P naught. So P naught equals 13%. Now, Enrica sent out a survey to the senior class, right? And the senior class has 150 students. But we have to be careful here. Only 100 students replied. And of those 100 students, 17 of them said that they walked to school. So really, P hat is 17% over, P hat is really 17 over 100, which is 17%. Okay. So HO is P equals 13%. And HA, Enrica thinks that the proportion is higher. So HA is P is greater than 0.13. And I want to be consistent, so I'm going to write P equals 0.13 as well. Okay. Here's our last one. Gregor Mendel, from 1822 to 1884, an Austrian monk, is considered the father of genetics. Mendel studied the inheritance of various traits in pea plants. One such trait is whether the pea is smooth or wrinkled. Mendel predicted a ratio of 3 smooth peas for every 1 wrinkled pea. In one experiment, he observed 423 smooth and 133 wrinkled peas. What is P naught and P hat in the smooth peas? What is the appropriate hypothesis? So, this one's a little tricky, right? He predicted a ratio of 3 to 4. And we're going to use this prediction as our true proportion. So theoretically, right? And if y'all remember this from biology and using your Punnett squares, theoretically, you should get 3 smooth peas to 1 wrinkled pea. So if we're doing 3 to 1, this means that in total, there's 3 smooth peas out of the 4. So our P naught is going to be 0.75. So P naught equals 0.75. P hat comes from the sample. This is what he actually discovered. So in his experiment, he had a total of, so we have to add these up, 423 plus 133 is 6, 5, so 556. And of those, 423 were wrinkled. So if I put this into my calculator, 423 divided by 556, I get 0.76. So P hat is 0.76. Now, we need to write our hypothesis, right? Our null hypothesis is the easy part. P is equal to 0.75. Now, what would our alternate hypothesis be? Well, they didn't really tell us, right? But we're going to assume that he's looking to see if this is equal to 75 or not. So this means that P does not equal to 0.75. I hope that this launch helps you have a better understanding and clearer understanding on how to find P naught and P hat.